Hello everyone, welcome back to another video. So today we'll discuss editorial for Codeforces round 996 due to it was pretty decent contest, at least for me. I got positive delta and I was able to solve first three problems without any penalties. The only thing which I noticed was that there was a lot of gap between C and D in difficulty wise. C was easier than normal seats and D was harder than usual Ds. So uh, there was a huge gap, noticeable gap between difficulty ratings of C and D. At least that's what I feel. So yeah, so let's move to the tutorial for all the problems. So the first problem is two frogs, and what we have is we have 10 lily pads which are numbered from 1 to n, and Alice and Bob are frogs initially positioned at lily pads A and B, and both of them are taking turns on jumping, starting with Alice. So Alice starts first, then Bob, then again Alice, then Bob, in this type of configuration. And in each player's turn, if the player is at position A, the frog can jump either to A minus 1 or A plus 1. That is any neighboring uh, lily pad. And at each uh, turn, each frog must jump. That means we cannot skip a turn. Now there are some restrictions that two frogs cannot occupy same lily pad. This means Alice cannot jump to lily pad that Bob is currently occupying, and vice versa. And if a frog cannot make a jump, then it loses the game. So these are some examples. Let me show you when first it's the skills itself. So uh, n is n is 2, A is 1, and B is 2. So Alice is at start first cell, Bob is at second cell. Now Alice cannot make a move, so Bob wins, and that's why answer here is no. Let's see different examples. 3, 3, 1. So Alice is at 3, Bob is at 1. Now here Alice turns, at Alice turn, Alice will jump to the previous cell. So something like this. This will be configuration after first move. Now at this stage, Bob cannot make a move because he cannot jump here and there is no cell before it. So here Alice wins. So answer here is yes. Now what are some observations here? Let's start with first. Whenever game ends, it ends at uh, game ends at at 1 or n positions. So whenever a player reaches to one of the end and other player gets to that neighboring cell of that end, then the player which is at end of that limit, that is 1 to n, if a player is at the end of that range, he loses. So our game always ends at 1 or n position. Now second observation is, let's say here there is Alice and here there is Bob. Now, what are possible combinations? Alice makes a move to plus next cell. Bob makes a move to plus next cell. Alice makes a move to next cell. Bob makes a move to uh, previous cell. Similarly, previous cell, next cell, and previous cell, previous cell. Now, if you see, initially the difference was b minus 1. After making move, let's say Alice moves x and then Bob is moving with y. X and y is basically the change. If Bob moves to first next cell, then x would be plus 1. If Bob moves to previous cell, then x would be minus 1. Now b minus a will be here. We can separate b minus a plus x minus y. Now this will have same parity as this, and x minus y will always be even. So what are our possible combinations? So first is 1 minus 1, it would be 0. Second possible combination is 1 minus minus 1, so 2. Third is minus 1 minus 1 minus 2, that is also even. And fourth is minus 1 plus 1, that is 0. So x minus y will always have even parity. Now b minus a same parity. Adding an even parity to a certain number does not change its parity. So what observation we can make is that after playing even number of moves, that is 2 4, after making 2 4 6 8 number of moves, the initial parity remains same. So if initially the parity was let's say absolute of a minus b position was 5, then the difference between positions of a and b can become 1, can become 3, can become 7, can become 9, can become 11, but cannot become something like 2 4 6 8. So parity will always remain same after making even number of moves, that is a single round. Let's say a single round is when Alice and Bob, both of them, make a move. So now we take all the differences, we take the absolute difference of both of them, both the positions. So absolute of a minus b, we take it. Now there are two possible options. One is that is odd, other is that it is even. Now that if it is odd, that means it can be 11 9 7 5 13, any number. And even can be 2 4 6 8. Now how can we decrease this problem? We can decrease this into a simple if else based on the property which we checked above, that 11 can be converted into 1. Similarly 8 12 or all the bigger numbers can eventually be dropped down to 2, because in if we make even number of moves, parity will remain same. So in certain number of move, in certain configuration of move, we can make the difference between the positions of both of them equal to 2 if the initial difference was even. Similarly, if initial difference was odd, we can eventually make the absolute difference between both the positions equal to 1. So we basically, what we need to do is, if it is odd, we need to solve the case when absolute difference between them is 1. And if it is even, we need to solve it when absolute difference is 2. So when absolute, let's try to solve it for uh, when it has odd. So something like this. Now here, Alice needs to make a move. So Alice can go here. Alice has only one option to go backwards. Then Bob follows it. So Bob comes here. Then next would be something like this. Yeah. So in this case, whenever difference is odd, Bob will always win. Now, whatever configuration you take B A B. There are, you can take odd number of cells after, even number of cells, or even before, odd later. Any type of configuration, Bob will always win, because whatever move Alice makes, the Bob will follow and decrease. Not exactly decrease, but try to corner Alice to one side. Now let's say if the difference is even, something like this. Now in this case, what will happen is Alice will make a move to corner Bob. So Alice comes here, Bob will remain here. So this is even case. Then uh, Bob doesn't have any option. He have to go here. So A, then here B, then Alice makes a move here, then Bob. Now Bob is cornered and Bob doesn't have any other option, any other move. So here Alice wins. So first we found uh, absolute difference of A minus B if it was odd, and if it was even. Based on observation, we found that we can make absolute difference between both the positions equal to 1 and 2. Now if when it was 1, Bob always wins, and when it was 2, Alice always wins. So for even, Alice wins. For odd, Bob wins. This is the solution for it. I don't think code is. Um, I need to explain the code. This is pretty simple. Take n, a, b as input. Find absolute difference. If it is even, print yes, that is Alice is winning. If it is odd, print no, that means Bob is winning. So this was the first question. Let's move to second. Second one was also pretty easy. Just one observation. There was just one observation. So first, we are given an n different types of magical materials, numbered 1 to n, and initially we have AI units of material I, and we have to perform a following operation. So we select an material I, then spend 1 unit of every other material. That means all the j's from 1 to n except j not equal to I element, and then ith material gains a unit, but all the other every other material loses 1 unit. So basically, if we select I, we can update AI as AI plus 1, and we have to update all the other elements. Let's represent those indices at j such that j is not equal to I and j is from 1 to n. then aj becomes aj minus 1. So aj must remain non-negative because we cannot decrease units if we have 0. Now, what we need to do is we need to craft an artifact using these materials, and to successfully craft we must have at least bi units of each material I. So from for all materials I from 1 to n, ai must be greater than equal to bi. So in simple terms, we are given an array a and array b. We can perform an operation such that we increment a of I to a of I plus 1, but cost of this is that we decrease all the other elements such that uh, j is greater than equal to 1, less than equal to n, and j is not equal to I. So performing these operations, what we need to do is we need to check uh, if it is possible to make all ai is greater than bi for I less than equal to n. Let's just see one example. So 0, 5, 5, 1, 1, 4, 4, 0. Now this is A, this is B. So let's start with index 0. At index 0 we need A of I at least equal to 1, because A of I must be greater than equal to B of I. So what we need to do is we need to perform operation on I equal to 0. Now how? So we basically increment A of I but decrement all other elements. So 4, 4, 0. So this is A, this is B after performing operation on I equal to 0. Now we move to next index I equal to 1. This is already satisfying, then move to 2, and then move to 3. All of them are satisfied. So we print yes, that it is possible to make such array performing the operation. Now second case is also pretty useful to make some observations. So 1, 1, 2, 2, and there is 3, 1. Now here answer is no. Now why is that? Because first of all we need to make I equal to 0 operation on first index, 0th index, because we need a of I 1 should be greater than, this one is not greater than equal to 2, so we need to increment it by 1. So to increment it we perform the operation, then it becomes 0, 2, and 2, 1. Now we have problem with I equal to 1. Now we need to increment this again twice, such that it becomes uh, greater than equal to 2. Now when you are incrementing this again, the original index which we are trying to make equal to bi, it will again decrease. So let's even if it is decreasing, let's perform the operation and see what happens. So ignore this for now, and whenever you do this, the 0th index again becomes uh, the condition fails at 0th index itself. So we again need to increase it. So it will become 2, 2, then 0, 2. So this 2 index itself are going into kind of infinite loop, for satisfying condition for each other's index. So whenever there are two indices, so this is main observation. So if there are two indices for which AI is less than BI, our answer is always no. We cannot perform any operation because whenever we try to increase AI, there would be another index which is like this will decrease, and whenever we again retry again try to increase this will decrease. So they will be dependent on each other, so this they kind of form a deadlock between them, and this condition will not be set. Both of them, for both the indices, the condition will never be satisfied, and hence answer will be no. So if there are two indices which has AI less than BI, not exactly 2, greater than equal to 2, then our answer is always no. Now then there is a case where the such elements are 0. When they are 0, our answer is always yes, because the array itself has already it's already satisfying the condition. We do not need to perform any other operation. Now if count of such indices is 1, that means there is only one index, a of I less than b of I. So in this case, what we need is we need b of I minus a of I units from all other elements. So let's call it as required. So we need required from all other units, all other elements except I. Now if we are at position aj and bj, j is another index except I, then aj should contribute to aj will contribute required number of units to make uh, the ith index. Value of vector value of element at index I in vector a greater than equal to bi, it will contribute required number of units. Now when it does that, it should also satisfy its own condition, that is, when I decrease that required units, it should be greater than equal to b its corresponding element in b vector. So this is the condition which we need to check when counter is number of such indices is 1. So these are the three cases where if the number of indices where AI is less than BI, it is if it is at least 2, answer is no. If it is 0, answer is always yes. If it is 1, we need to check this. So solution for this. First of all, what I'm taking input all the vectors, then I have declared a counter, and then I have declared a mn variable and a ch variable. So first of all, iterating over the array, and if a of I is less than b of I, then counter plus plus. And I'm also storing the maximum difference between b of I minus a of I. And if a of I is greater than equal to b of I, then I'm just storing minimum of a of I minus b of I difference. Instead of checking all the elements, we only need to check the minimum one. So a of j minus required is, let's say, greater than bj, then what we can say is that is greater than equal to required. So whatever the minimum value of this is should be greater than equal to required. So mn basically ch basically stores the required value, and mn stores minimum of all the elements such that aj is greater than equal to bj. So first, if cnt is greater than 2, just print no and return. If cnt is 0, print yes and return. Then if mn, whatever minimum value is greater than equal to the required number of units, print yes, else print no. So this was the second question. Now let's move to third one. Third one was is an interesting question. So in this question, what we are given is a grid n cross m and a string. First of all, n and m is given, then a string of n plus m minus 2 length. I think, so, yeah, n plus m minus 2 lengths string is given, and we are given a matrix of n cross m. Now, there is a path in that matrix of zeros which is used to travel from cell 1 comma 1 to n comma m. So let me just give you one example. So 3 is there, the string is ERRD, and so 3 is an NM, and this is our matrix, and this is the string given. Now we start with the first cell, which is this. So let's mark it as star. Then this string, it represents a path from starting cell to the n cross m cell. So from 1 1 we move down. First letter is D. Then we move right. Then we move right again, and then we move down. So we are given a path with this string which is starting from 1 comma 1 and ending at n comma m in n cross m matrix, and all the cells on that path have value 0. Now what we need to do is we need to fill these zeros on that path with some values such that all the columns, all the rows have same sum. Let, let's just check the answer for getting better idea. So 1 2 3 3 1 2 and 2 3 1. So this is the answer for this. There are multiple answers for this, but this is one of the answer. So all the cells which are not 0, which are not on the path, remain are same as it is, but the cells which were on path are filled. So these 5 cells. Now these are filled such that each row and each column has same sum. So first row has sum equal to 6, second row also has 6, third row is also has 6, first column also has 6, second and third. So what we are asked to do is to fill this path with integers from minus 10 raised to the power 15 to 10 raised to the power 15. These are the limits. You can fill it with any number in such a way that all the rows sum and all the column sum should be equal. That means this row, this column should also have some equal. This row, this column, this row, this row, this column, this column. All the rows, all the columns should have same sum. So first and very important observation here, we are given an n cross m grid. So let's assume that we make sum of each row and each column equal to a variable sum. Let's assume it. Now let's find the sum of complete grid, total sum of grid. If we find it with the basis of rows, then it would be n into sum, because n is number of rows and each row has sum equal to some variable. Now if we try to find it with columns, then it would be m into sum. That is, m is the number of columns and sum is sum of each column. That means n into sum equal to m into sum. Now here are two cases when n is equal to m and when n is not equal to m. So when n is equal to m, sum can be anything. Sum can be any integer. If n is not equal to m, then the only option is when sum is equal to 0. Here also sum equal to 0 is also possible, but any value of this variable is possible. But in when n is not equal to m, only possible way is sum equal to 0. So based on these two observations, it is always better to consider the sum of each row is equal to 0. Both the conditions will satisfy and it will generalize our solution instead of going into different cases. So now we have fixed a value, the total sum of each row, which will be 0. Now let's just take one path. Let's just take this above example. So 0 0 0 0. This was the path, and now first of all, what we need to do is we need to we can start with our first cell, filling this first cell. Now what on what basis this cell filling this cell would be optimal or would be better? Now if we try to fill it based on its column, so we will have two unknown variables. So first of all, let's say if we fill this first cell with x and second cell with y, so what we get is x plus y plus 3 equal to 0, which is the sum which we have fixed to be so this is fixed, so we have to make all the rows and columns sum equal to 0. So if we take by column, x plus y plus 3 would be 0. Now we cannot solve this equation because there are two unknown variables. Now if we try to solve it on basis of row, so x plus 2 plus 3 equal to 0. So we can say that x is minus 5. So we fill this x with minus 5. Now once we resolve this, then the trailing element of this, the next element of that path can be solved. So in this equation, x plus y plus 3 equal to 0, put minus 5 plus y plus 3 equal to 0, so y would become 2. So we have 2 here. So these two are done. Now the next element. So this again, doing this on row is not best option. We have to do it according to column. So 2 plus 1 plus unknown equal to 0. So unknown would be minus 3. So this would be minus 3. Now we can solve this either based on column but also based on row. But solving based on row is optimal because there are no other unknown variables here. So cut this 2 minus 3 minus 1, so it would become 1. Now this is then the last element. We can fill it either based on row or column. Both have no unknown variables, which will be minus 4. So we basically have the solution as minus 5 2 3 2 2 minus 3 1. This is minus 4, this 1, and this is 3. So we were able to create such matrix. So what we need to do is, let's say there are two consecutive elements on the path, unknown variables. Their configuration can be something like this. So if you are moving right, there would be additional unknown variable on the right side in the same row, and if you are moving down, there would be additional uh, unknown variable in same column. So whenever we are moving right, what we will do is we will fill the first element based on rows sum, and whenever there is a column, we will fill the first element's value based on row, and keep doing this until we come to the last element, that is n cross m cell. So this is the solution. First of all, we fix sum equal to 0. We come to this conclusion, and then simulate that solution based on that conclusion with starting cell as 1 1 1, and keep doing it up to n cross m with this strategy. When the consecutive adjacent elements are uh, on in the same row, we do the check, we fill the value according to row, and when it is column, we fill according uh, when it is row, we will fill according to column. When there are two consecutive elements in same column, we will fill according to row. Now I this will be this will be uh, possible to fill because there would be no other unknown variable in that column. Why is that? Because whenever we are coming this path, this will already be filled. Similarly, if we are coming from this path, this will already be filled. That's why we do this according to the configuration. So let's just see the solution. I will also show you the first solution which I wrote in around 26 minutes, I think, and this was around of almost 1 hour later, which was accepted. So this is the correct solution first. First of all, taking all the input, then I have declared two maps. One is row, one is column and row. So th those two maps stores the sum of each row. So ith row, I'm incrementing a of ij. So in ith row there is an element a of ij. So I'm just adding it to that map. Similarly, column of j plus equal to a of ij. Then what I'm doing is I'm starting from 0 0 index. This idx2 is used to iterate over the string, and this is total what the total sum which we have fixed. After coming to conclusion, we have fixed it as 0. So total here is 0. Now whenever the string element at idx is d, that means we are going downwards. Now going downwards means we have to fill the current element with row according to the sum of that current row. So the required would be total minus row of I. We all the elements in that row are filled, whose sum is stored in this map row of I, and we need to make total sum equal to this variable. So the required sum would be 0, that total sum minus the current sum. Then a of ij will be, I will fix it, I will put it in that cell, increment the required increment that newly increment the element according to its respective row and column and move down. If we are moving down, increment I. Similarly, if uh, that element at that index was rightwards, if we are moving towards right, then we do this, we set the element according to column sum. So total minus the current sum of that column, we fix it, change the sums of that row and column, and increment j, and finally increment the index of s. Now this will fill all the elements except n cross m, the last cell element. So for that we need to fill it. We will fill it again. We will fill it here, and finally we will print the vector. Now the uh, uh, first the first solution which I wrote, it's same as it is. Just here I assumed that for any sum it would be possible. So here I just changed the total whatever target sum which we are trying to achieve as 10 raised to power 11. I just assumed a big number with that within those constraints and tried writing the solution. Now this is same as this, just total equal to 0. Now the difference between times of both the solution is 30 minutes. So coming to this conclusion took me 30 minutes, you can say. I will also show you the same codes and what is the difference between them. So this is the solution which is accepted. As you can see, total here is 0. Now for each test case, what I'm doing is I'm printing the sum of column and row after updating all those things. As you can see, all of them comes out to be 0 0 0 0. So this satisfies the condition. Now if I make it equal to 1e11, let me just print. So this is first test case. Now column sum is equal, all the rows sum is also equal. Now why is both of them equal? Because here n and m are equal. Now if we take second case where n is 4, m is 5, then this condition is not satisfied because four columns have same 1e11 sum, but last column has 0 sum. Similarly, third case will also fail because n is not equal to m, but fifth case will satisfy because n is equal to m. So just wanted to show you this proofs actual implementation and how it works. So if we keep it any other element except 0, the test case which have n and m equal, they would work. But the test case where n is not equal to m, they will not work. So pretty decent contest for me also. I got positive delta. And D was pretty difficult than C, I would say. Cap is too much. I will try to solve it, but and I guess that's it from my side. Thank you for watching.